Everything that has a beginning has an ending. This, as an expression in English, goes back a long way. The dinosaurs came and went. We the humans take birth, live our life and eventually die. About 5 billion years from now, the sun will swallow our blue planet and later even the sun will end its life becoming a white dwarf star. Not only the sun, rather all the stars will run out of fuel one day and meet their end. But what about the fate of our universe as a whole? Will our universe also come to an end? If yes, what are the possible scenarios? This is Q&A, and here is the answer to the question, how will the universe die? Well, the question about the ultimate finale of our universe is something that has troubled the cosmologists for a long time and is still doing so. In order to seek answer to this important question, several hypotheses have been put forward time and again, each pointing towards a different tragic story. In all these theories, Einstein's general relativity has played a major role. Now, since we are dealing with something as big as the universe, there must be a certain factors on which our theories are based. To be precise, there are 3 factors. Number 1, the average motion of galaxies. Number 2, the shape and structure of the universe. And number 3, the amount of dark matter and dark energy that the universe contains. Taking these considerations in mind, a number of possibilities about the end of the universe have been hinted. The first is the Big Freeze. This theory is based on the second law of thermodynamics. We know that the universe is expanding and thus cooling. The Big Freeze is a scenario under which this continued expansion will result in a universe that will asymptotically approach absolute zero temperature. This means that no temperature difference would exist. But as far as we know, according to the laws of thermodynamics, every process in our universe requires some kind of temperature difference either directly or indirectly. So, in the absence of any temperature difference, all the interesting phenomena will cease to happen. Nearly all the matter will decay and every star will die. The universe will grow darker and darker. Eventually, black holes will dominate the universe, but they will also disappear over time by emitting Hawking radiation. So the universe will end up uniformly cold, dead and empty. But don't panic. Even if this hypothesis is true, it will take about 100 trillion years for our universe to reach this vicious stage. The second is the Big Rip. In our universe, 2 processes are occurring simultaneously. On one hand, expansion is taking place and galaxies are moving apart, and on the other side, they are getting attracted towards each other due to gravitational effects. However, according to the Big Rip theory, one day a steady increase in the Hubble constant will occur, which will lead to the dominance of expansion over attraction, hence disintegrating everything. This expansion would pull the Milky Way apart, sending its constituent stars to fly away in disguise. The solar system would become unbound. Even the atoms themselves would shatter into unbound elementary particles, radiation and beyond, ripping the universe apart. The next is the Big Crunch. Contrary to what happened in Big Rip, this theory assumes that one day the average density of the universe would become large enough to stop its expansion and begin contraction. This would cause the matter and space-time in the universe to collapse into a dimensionless singularity, back into how the universe started with the Big Bang. Isn't it like the Big Bang being played in reverse mode? It's definitely like being back to square one. But according to the Big Bang cosmology, our universe originated from a singularity only, right? So, isn't it possible that this singularity obtained as a result of Big Crunch is capable of giving birth to a new universe via another Big Bang? Well, this is what our fourth theory, Big Bounce, says. In simple words, Big Bounce is the amalgamation of Big Crunch and Big Bang. It proposes that the universe will continuously repeat the cycle of a Big Bang, followed by the big crunch. Yes, a continuous cycle of creation and destruction. So now, it's the time for the last and the most recent theory in this regime, the Big Slur. This theory came after the Higgs-like particle was discovered in 2012 at CERN's LHC. The Higgs field, as we know, is omnipresent and gives mass to everything in this universe. And the Higgs particle is simply an excitation of this Higgs field. Using a simple daily life analogy, consider a glass of water. Everything is calm initially, but when you add an ice cube to it, the water splashes all over. This splash of water is what the Higgs boson is. When the Higgs field is excited by a massive external energy, the splash of energy is the Higgs boson. So the detection of this giant suggests that the universe is in an unstable, excited state. According to scientists, if it is in an unstable state, in billions of years it could tip over the edge, causing a bubble to appear, possibly from another universe. This bubble would then begin to expand at a rapid rate, annihilating everything in its path. It is expected that this destruction would occur instantaneously, without any forewarning. The scenario is indeed petrifying. But nothing is certain yet. All these possibilities have been described using the dark energy equation of state. And as for now, we don't know much about this mysterious dark energy as well. So definitely, a number of speculations lurk around all these possibilities about the end of our universe. However, if the currently accepted parameters about the shape of the universe and all are concerned, Big Freeze seems to be the most probable fate of the universe. But as I mentioned earlier, nothing is certain. Share this video with your friends. See you in the next episode of Q&A.